Jason Grigsby is co-founder of Cloud4, an agency based in Portland, Oregon. He's also founder and president of Mobile Portland, a local nonprofit dedicated to promoting the mobile community in Portland. And he's the author of the book Progressive Web Apps. Over the years, he's worked with a lot of design patterns, and he's about to share some of that experience with us. Please welcome Jason Grigsby.
For a few years now, I've had this dream when it comes to design systems. I want to be able to create a component, a fairly simple component, and be able to take that component and replicate it multiple times and have it distributed to different teams in an organization and have those teams be able to build whatever it is they need to build, but be certain that the component continues to have the integrity of our designs. Now that seems like it should be easy, but in fact it turns out to be quite a bit of a nightmare. Because we'll have this component that looks perfect and does exactly what we want and fits the brand, and then we'll see a team adopt it, and well, it's close, but it's a little off. The color's not quite right. Oh, hey, I'm sorry, we haven't been using rounded corners for 2 or 3 years now. That's cool, but that's not part of our design system. I mean, I get that it's flexible, but could you use something in the design system? I don't even know what to say to that. The color looks close. It doesn't look anything like, yeah, I get that you're proud of it and you can build cool things, but that's not what we need. I think a lot of this comes back to what Nathan Curtis has written about when he talks about design system intermediaries. So he outlines these 3 intermediaries that sit between your design system creation and the people who want to adopt the design system. So the first are distributors. These are people who work on the platform, sort of like design ops people who make sure that the dependencies that are necessary for the design system are on people's laptops and distributed as necessary. Then there are translators. These are people who take the design system and convert it into their tool or framework of choice. Then there are themers. Themers want to take the design system and translate it into their brand or sub-brand. I want to focus on translators because I feel like this is where I see the biggest challenge in the organizations we work with. So we will typically create our design systems in HTML, CSS, and JavaScript so that it can work with whatever framework someone wants to use, whether they're using React or Angular or Vue or AM, whatever it is. Because we've built it with vanilla code, it will work in those systems. But the problem is that there's always an active translation from what has been defined in the design system to what can be used in those particular frameworks or tools. In other organizations, sometimes people will try to say, okay, we're going to create something we're going to try to standardize on React, and everybody has to use React. But inevitably, there's going to be some old project or some new work done by a third party or something of that nature that comes in that's going to be using some other system. And then we're back again to this need to translate it. And the fact that the translations always look wrong in some fashion or perform incorrectly. A few years back, my business partner, Tyler Sticka, wrote this article about how there are 3 characteristics of what he considers a successful design system. That it's user-friendly, that it's easy for people to understand how to use a system and to use it as documented well. That it's collaborative, so that it's possible for people to be able to contribute new components back to the design system. That it's clear what happens when there's a use case that wasn't accounted for. And that it's integrated so that the components go directly into whatever the products or applications are that need it. Now, Tyler, in writing the article, said you should pick any 2 and do really, really well at those 2, because if you do, then you can be successful. What he didn't say is that it's really hard to do all 3, and that the integrated part is the hardest part. When we talk to clients, they'd oftentimes decide that they didn't want to take that on. So over the years, I became a bit depressed about this idea of just being able to design something and have it, see its way through all the systems in these organizations. But over the last couple of years, I started to notice these hints that maybe something's changing. The first is just simply that our profession has changed a bit. People who are doing web design aren't thinking so much about web pages anymore, or at least some of us aren't, and are thinking more about how to design systems of components. It's become so common that there's a lot of articles where people are asking for container queries or trying to find solutions for container queries. And the whole need for container queries is an acknowledgement that we want to be able to define rules for these smaller pieces of a page, not the entire page, which is what media queries allow us to do. On the JavaScript side of things, we've moved from jQuery, which was DOM manipulation and AJAX, to frameworks that really emphasize component creation. Now, these aren't necessarily all the frameworks that you might choose, but most modern frameworks are really they're focused on this idea of component creation. On the design tool side of things, we've seen a shift as well. So Airbnb wrote about how they have taken React in their design system and actually created an open source tool that converts it into sketch files so that their designers can use the actual components that are part of the design system in their designs. And there are a lot of design tools like UXPin that are built on top of the web that are also looking at bringing in design system components into the design tools directly. Content management systems are seeming to do something different, although they tend to refer to them as blocks. So Gutenberg for WordPress has this whole block-based editing system where there's a series of blocks that you can add to any given page, and there's a whole host of different types of blocks that you can add. And when I look at this list of blocks, all I see are the different components in a design system. They're not that different. A couple of years ago, Bloomreach did some articles and published a presentation talking about how to take headless CMSs, which in the past had no way to actually see what you were editing, and make it possible to see what those changes were. And their solution was to take single-page applications, pages that are built using whatever those JavaScript frameworks that somebody might choose, and actually have them embedded inside of the editor in an iframe. And then as edits are made to the content management, behind the scenes, the content management system tells React or tells Angular, this particular component has been updated, please refresh that area of the page. And so from a user perspective, it feels like you're editing something just as quickly as you might in Gutenberg in WordPress, but actually what's happening is that you're editing a single page application that can exist on an entirely different server from the content management system. And then there are web components. Web components is a standard that's been around for quite some time. At this point, it feels like it's been around forever, but it's not gotten quite the adoption of other standards. I think there's a bit of a barrier to entry, but web components are designed for defining components that are reusable, and that is a lot of what a design system is. And at some point, I looked around and realized that there's components all the way down. Everywhere I turned, there was a component. I was a little worried that this was a bit like when you're looking for a dime on the street, you find a dime on the street because you aren't looking most of the time. But if you are looking for money that somebody might have dropped, then you find it. Was I looking for components and just finding them? And then I saw this tweet from Max Lynch. Max Lynch works for Ionic, and he wrote about how for years now they've been rebuilding their UI frameworks so that it would work in React or Angular or whatever. And now they just build their web components and then convert them to the other systems. As I mentioned, Ionic, they create these mobile UI toolkits. It's a really nice system. It's got some very nice development, but their open source story is actually, I think, the even more impressive part. Max wrote about how you should build your next design system with web components. And after I read this article, I started wondering, is this the point where it's actually possible? Maybe we can actually take a web component, convert it to Vue, Angular, React, Ember, bring it into design tools like Sketch, InVision, Framer, and UXPin, and then into CMSs like Bloomreach, Adobe Experience Manager, and Storyblock. I wasn't sure whether it was possible or not, so it was time for an experiment. I enlisted my colleague Paul, who's a designer and developer at Cloud4, and he's brilliant. I couldn't have done this without him, to help create an experiment that would test how far we could take it. How, if we built a series of web components, how many tools and systems could we bring it into? So first we had to decide what we were going to build. We came up with this idea of doing an e-commerce site. Paul did some quick sketches of, basically an e-commerce interface. We wanted something a little bit more complex than a blog, but also something where there would be some freedom to sort of change the layout, but there would also be some functionality. And out of that, we created a list of demo web components that we needed to create. Before I go on, it probably makes sense to talk about what a web component is. Web components allow us to define our own custom HTML elements. So for example, in this case, we've got a web component that's called C4-button, and that creates that button that's at the bottom of the screen. We can also define whatever attributes or functionality we want the particular element to have. So in this case, we've got a series of attributes that change the appearance or change the functionality of the buttons. Web components consist of 3 different standards. The custom element standard, which allows us to create new custom HTML elements. The shadow DOM, which defines how we create a shadow version of the document object model, which we can use to encapsulate any styles or markup that we don't want to be affected by the surrounding web page. And the HTML template standard, which defines how we can create fragments of markup that we want to use later. So let's look at how we created the C4 button. Now, before I begin, let me reassure those of you who don't spend your days in code that this presentation isn't going to be code focused. And for those of you who do spend your days in code, I'm very sorry. The point of the presentation is really to see how far we can push these web components. I do think it is important to just take a moment and look under the hood at how the web components are being built. But I'm not going to teach how to build web components. There are a lot of other tutorials that do a really good job of that. Instead, I just want people to have a general sense of what's going on so that if you're having conversations with others or if you want a starting point for going off and doing your own research, you've got that. So we're looking at a JavaScript file that's going to define that C4 button. All web components are defined in JavaScript. So this is one of the first barriers to actually creating new elements, is that you have to be able to write them in JavaScript. At the beginning of the file, we've got a series of styles. And then at some point we get down to the point where we're actually doing the web component work. So first we're going to extend an HTML element. This could extend a particular existing element, so we could have extended the button itself. But in our case, we wanted to be able to use the sort of more generic HTML element so that we could have our button support both buttons that use the button element and anchors that look like buttons. And you'll see later where that's happening. Now down here we're defining what sorts of tags we expect the element to have. So we're saying we expect it to declare whether it's going to be a tag or a button. We're expecting some classes. You can also define if it's disabled or not. And now if it is a tag, then we're going to output this markup here. And this slot is where the content between the opening of our custom element and the closing of the custom element, whatever's in between there is going to go right into that slot. If it's a button, we're going to do similar things, but instead we're going to use this markup. And then finally, we define our custom element, and we say that the syntax for the custom element, or the sort of tag itself, is C4-button. When we go to import this into a web page, we first have to make sure that we actually declare that we need the script that defines that custom element. This is a challenge for situations where you want to make sure that you're supporting progressive enhancement, because if that script isn't available, these custom elements don't mean anything. It's part of the reason why we tend to think about web components as part of design systems and sort of pieces of a puzzle, and maybe or maybe not what actually is delivered to the end user's page. So you can see a series of different buttons and the classes attached to those buttons and whether it's disabled or whether it's an anchor. If we look at this in action, what we'll see is that we have those buttons. Let me zoom in here a little bit. And hover has certain characteristics. Disable button works the way that we would expect. If we inspect a button, what we'll see is that inside the button there is the content, but there is also this shadow root. And inside the shadow root are all the styles that we defined, as well as the markup for the button. If we look at the link that looks like a button, and we look inside that particular instance of the C4 button, we'll see that in here we again have all those styles, but the markup is actually an anchor tag. So that's sort of the basics of how this button is done. There's a lot more to components and they can be much more complex than this, but that gives you a general sense of how web components work. While web components are nice on their own, we wouldn't be able to do this experiment without Stencil.js, which is an open source framework from Ionic. Stencil.js is what Ionic uses to be able to take their UI framework's components and translate them into the different JavaScript frameworks. The reason this is nice is because a basic web component includes encapsulation, the shadow DOM, ES modularity, which allows us to incorporate JavaScript modules in a standard way, and HTML templates. And those are all nice, but the reality is most of the time when we're working with web components, we're also going to want to be able to do CSS processing, server-side rendering, reactive data binding, the virtual DOM. We're going to want to have declarative templates. And those features aren't baked in, but they are part of a stencil component. So you can think of a stencil component as sort of a more powerful version of a web component. The nice thing about a stencil component is that it will compile to vanilla web component. And because it's going to do that compile process, we can also output more than just a web component. We can render a static bundle of assets, we can output documentation, and Stencil includes output targets where we can take the components and then translate them into Vue, React, Angular, Ember, and other JavaScript frameworks. So Stencil components are a lot like web components. As a matter of fact, Stencil components are just sort of a bunch of additional tools and utilities and things that you might need when you're building web components. And these utilities make the definition of web components much easier to do, or sort of cleaner and faster. So for example, it's a small thing, but using Stencil, we can separate out our CSS from our JavaScript. So we have just a C4 button CSS file. When we look at the JavaScript, what you'll notice is that it looks a bit different, and that's because it's not vanilla JavaScript, it's actually TypeScript. And again, we can use some of the features that Stencil brings in from its core to define how the component will work, and to define it actually pretty quickly. This is a lot less code than what we're looking at from the pure web component perspective. But what's really nice about Stencil is it provides a bunch of additional utilities that you get sort of out of the box. So if we go in and we actually start the Stencil project, it will go in and it'll build that. And if we've defined anything where we want to output the components into other areas, we can get access to those as well. So these are the Stencil components. We've got some buttons and some steppers and star ratings, color pickers, sizes, things of that nature. And in addition, we can also reference these in Storybook. Storybook is a tool that allows us to look at design systems in a web interface and contains documentation around those design systems. So as part of our Stencil configuration, we're actually outputting the web components into Storybook, where we can then have access to them. So if we go in here and we look at the components, we will see our buttons and all of their different options, including documentation for how the buttons work, and additional things like if we look at star ratings. And for any of these components, we can see how you're able to modify the interactions for the components. So as we adjust these star ratings, or we change the number of reviews that are available, these items also change on the canvas, so we can see how the component is working. So all of the components are defined and accessible in our Storybook instance coming out of Stencil. And just to show you one more thing, we've taken those components and actually output them to just a basic web page as part of an Express app. Express is just a very simple web server that we're using to serve up this HTML document that contains all of the web components that we have defined. So that we have sort of a Stencil version, a Storybook documented version, and just a pure basic web component version that we can reference. Let's use that map that I shared earlier to track our progress towards being able to take components and distribute them into all of these different systems. So we'll give ourselves credit for having created web components, and the next task is to figure out how to take those web components and convert them into different JavaScript frameworks. Fortunately, Stencil.js has the ability to use output targets for different JavaScript frameworks. It already has output targets that support Angular, React, Vue, Ember, and most recently Svelte. We're going to use those output targets. So with Stencil, we can define these output targets. In the package JSON file, we're going to add a few dependencies for Angular, React, and Vue. We're not going to add one for Ember because Ember sort of works with web components pretty well right out of the bat. But those are the 4 frameworks that we're going to target: Angular, React, Vue, and Ember. So we declare those dependencies, and then in the configuration, we tell Stencil where it should put those components. So we actually create a series of directories for the React components, Angular components, Vue components, which you can see over here. We've got a directory for the React components and then the React app itself. Similar things going on for the Vue app and the Vue components, Angular, etc. The end result is that if we look at this in a browser, we can see that we have a very similar page to what we were looking at before in Express that was just generic web components. But in this case, if we actually inspect one of these items, what we see is that it is actually a Angular component. So we can see all of the sorts of attributes that we expect from an Angular application. Similarly, if we look at React version of the page, we see all of the same components. And in addition, we have all of the props for that particular component in React available to us. You can sense that there's going to be a repeating story here, where if we look at Vue, we see very similar in Vue. And again, if we look at something like, say, actually, let me look at the star ratings here. We'll see the ratings and the various props that are defined for that particular element. Same thing true for Ember. So we have taken a series of web components and translated them into 4 different JavaScript frameworks. Stencil also now appears to be supporting Svelte, but it's fairly new, just like Vue. And our experience actually in general with output targets is it can take a little bit of time to finagle them and get them working correctly, but once you do, it's really nice. You can also use Stencil without those output targets. It generally means creating wrappers around the components so they can be used in each of the frameworks. But if you can use output targets, it's much nicer because it just gets taken care of automatically for you. All right, we've successfully converted our components into JavaScript, so let's take credit for that and let's move on to design tools. And we'll start with Sketch. As I mentioned earlier, Airbnb has created an open source library that converts React into Sketch. They use it themselves. This had us very excited about the chances of being able to convert our web components that are now in React into Sketch. Unfortunately, what we found was that the React Sketch app doesn't support regular React. It only supports React Native. And that won't work with our sort of web standards-based view of the components that we wanted to build. There is another open source project called HTML Sketch App that was inspired by the React Sketch App that attempts to move to just basic HTML as opposed to using React. There are quite a few limitations on this library. It's fairly young, but it can do some really amazing things. Unfortunately, when we tried to use it on our components, we immediately got an error, and we thought that we were sort of dead in the water until just a few days before recording this presentation, when somebody came in and said, actually, the problem is with this plugin, and here are the steps to fix it in the meantime before we can actually update it in our source code. So we decided to give it a try and see what happened. Well, if the bug is fixed, let's give it a try. So we applied the patches, the recommendations that were suggested, and we're going to try to import this particular web page. This is the Express app. So as a reminder, Express app is just a simple web server, and on this page we've got the web components that we've defined. These web components, just real basic page, but we're going to try to see if we can take these web components and import them into Sketch. So we're going to use a script that they have that will take a URL and attempt to import it. So we're going to use this HTML sketch app example to see what it will do from an import perspective. So we're going to run it against that URL, and it is apparently done. And we're going to switch over to Sketch, and then we're going to use this plugin that they have to import this AS sketch file, so almost sketch file, into the document and see, oh, it's successful, but it does not look successful. And this is where I got stymied before and was very disappointed, but look at what's hiding out under this box. It doesn't look exactly the way that we expect. As a matter of fact, I think part of the problem is that the fonts are wrong. So let's actually replace it with Source Sans Pro, which is our typeface. And we'll replace it and we'll be done. And then things are looking a little bit better. But then we also have problems with this should be, that should be behind it, and that really needs to be white. And you can kind of see that there's some problems here. It's not perfect, but you can see that it's promising, right? Like, we've got the web components into our page. Now, I think it would work better if we were dealing exclusively with React components, or if we weren't doing web components, which have some challenges. And as time goes on, I think these open source libraries will get better. But this is a promising start. Well, that didn't work exactly the way we were hoping. So I don't know. I don't think we can give Sketch full credit for importing our web components. Maybe we'll give it half credit. I think that there's a good possibility we could sort out how it works, but it's going to take a little more time. Let's take a look at Envision. So Envision has this design system manager that actually looks like it does exactly what we want it to do. I want to show you a little video that shows how it works.
Historically, design patterns, coded components, and documentation have existed in 3 separate sources of truth, creating a divide between design and development. Live components in DSM create a true single source of truth, bringing design patterns, coded components, and the documentation that ties them together all in one view. Live components work with Storyblock, supporting frameworks like Angular, React, Vue, and HTML.
So this sounds perfect. It's got Storyblock, it's got Angular, Vue, React, all of the things that we're doing right now. Unfortunately, the reason why I'm showing you this video is that I was unable to get access to Envision DSM. It's an enterprise product and we're a small company, and despite the fact that I attempted to reach out to friends who seem to know people in the company, and then eventually reached out to their sales process, and then begged on Twitter, I wasn't able to find somebody who understood what I was trying to do and could give me access to the product so that we could see whether our experiment would work. That said, I'm fairly confident it would. I did find one little FAQ that gives me a little pause, which is that they say that their Storyblock integration doesn't support Stencil and Polymer, and we are using Stencil in this experiment. But we've been able to make the web components that we're working with work in a lot of systems that didn't necessarily say that they support web components. So I think that it's still a pretty good chance that we could make it work. So I don't know what to do with Envision. We never actually got access to it. Their demos and stuff do make it seem like they're right in lines with what we're trying to do. So maybe quarter credit? I don't know. Let's move on to UXPin. So UXPin has a new product called UXPin Merge. And this particular product is not available for the general public. It's only available in a beta program. You have to ask for access. And fortunately, in this case, they gave us early access so that we could play around with it. UXPin provides a couple of different ways we can bring our design system into their tool. We're going to look first at UXPin Merge's command line interface. Now, this is an experimental beta product that hasn't been released yet, and so there are inevitably bugs in it. But if we hit npm start, what will happen is UXPin Merge's command line interface will run, and it will open up a web page. And this web page is communicating both with the UXPin servers and also using code that's running locally on our system to provide us with those web components that we can see in the left-hand side. Actually, I should say Web Components is a bit of a misnomer because UXPin is expecting React components. And so these are the components converted into React and then brought into the system. You can see that portions of this are looking the way that we expect. We see the stars, we see the color swatches, the container with its dark theme, but portions of it aren't quite right. Like the button here is cut off. And when I go to select the stars, for example, the box for the stars is actually tiny at first. It takes me a bit to resize it to be the correct size. But it does work the way that I expect. So if I change the rating, it goes down to 3 stars. Or if I select, for example, the color swatches, and again, the box is too small, but if I went in and added, say, I don't know, red, one too many zeros, it will actually work. Now, we can see the potential here in this system when we look at the overall, the live UXPin app. So if we go in and we edit a design, here again, we've managed in this case to push our general Cloud 4 components into the system, and that's why we can see these buttons and things of that nature. But you can also see that UXPin has these additional libraries. And if we look at, for example, the Bootstrap library and look at the components that are available to us, we can see how easy it is to bring those items into the design and then adjust the size of them or make designs, basically create whatever we want. And so there seems to be some real power in being able to do this. And at some point very soon, it seems like we're going to be able to have a reliable way to bring our components into UXPin so that we can take our design systems and give them to designers to design with. It's just not quite there yet. Okay, so UXPin got further than any of the other tools that we did, but it still wasn't working fully, so maybe we can give it half credit. I think that because it's in beta, that there's a good chance that the wrinkles we saw will get ironed out as it goes into its live product. Finally, let's look at Framer. So Framer has both a web application and a desktop application. And for the desktop application, there's quite a bit of documentation how to get existing React components into your canvas, into your Framer desktop application. So let's take a look at how it works. Framer is where we can see the potential of having our design components, design system components in our design tools really come to fruition. So in Framer, we had so much fun playing with our design system components that we created a series of mockups. Let me just zoom in on one of them here. So take a look at this MacBook one. We have all of these components, and they're actual functional components. I mean, they're Cloud 4 socks. Of course, everybody would give them 5 stars. As a matter of fact, people love them so much that there's going to be 200 reviews. And look, those are the reviews. They're right there. Maybe you want to change the color. I don't know, maybe a little lighter blue. That's certainly possible. All of these is possible because these are actually the code. They're the underlying code that we wrote for the web components are there in the system. And that means that if we create new mockups, we have the ability to bring in all the components that we created and have them function the way that we intend them to function and look the way that we intend them to look. And we can do that all through the design tool. And I believe that this is where all of these tools are headed, whether it's the open source projects that are trying to bring stuff into Sketch, or whether it's InDesign's Design System Manager or UXPin's Merge. All of them are working towards allowing designers to leverage the design system assets and components in their day-to-day work. And this is really, really exciting stuff. Yay! We finally have a design tool that fully incorporates our web components, and the other ones look pretty promising. Now let's move on to content management systems, and we're going to start with Bloomreach and Adobe Experience Manager. We're going to cover them at the same time because they are both enterprise content management systems that, much like InVision's design system, I was unable to get access to, but I have a lot of information about how they work. In particular, Adobe's got pretty good information about how the spot editor works, and it's actually pretty similar to what we see for Bloomreach and others. So inside of the editor, there's an iframe, and that iframe is populated with some single page application. For Adobe, they only support Angular or React. On that page, we would have a series of components in whatever that framework is, and those components would be powered by content coming from the Adobe Experience Manager. In addition, there's an editable overlay that's only visible when you're viewing the page inside of the SPA editor. This is a little bit of code that's added around the components inside of the page so that the editor knows what should be editable. Once you hover over one of these components, you get the ability to edit it, delete it, make whatever changes make sense to that component. If you make a change, those changes get posted back to the content management system, and then the content management system stores it and then notifies the single page application in the page that a particular component has been updated, so that the React application or the Angular application then can re-render that content on the page. So that's how AM works. It's actually very similar to the way Bloomreach works. But I want to show you a video from Bloomreach because this is actually what got me really excited about the possibilities of being able to bring our components fully into content management systems. The person presenting doesn't work for Bloomreach. It actually works for ING, which is a customer of Bloomreach. And this was shortly after Bloomreach had purchased this company that made Hippo CMS, which is an open source CMS. And so you'll hear them talk about Hippo CMS. Hippo CMS and Bloomreach are essentially the same at this point in time. But this was a few years ago. I want to play the video now.
All the functionality I normally have available in Hippo is still available. So I can drag these components around. It's no problem. Just works. I can do inline editing of the content, and that should also work. Let's see if I change some text. And so as you can see, there's not much of a difference between the experience you normally would have with Hippo or the experience with web components. But what I'm gonna do now, and this is what I like, because all the actual markup is in the web components, I can replace the web components easily. So I will check out another branch of my web components. Oh, wait, let's just like this, which is a branch I created for today. And if I now go to another page in the channel manager, it will get a different definition of my web components, and suddenly I have a completely different website. So I could have a different menu, I have a different footer. The same goes for the site which is running. It's just a completely different website. Content editing still works. I can still drag around these components, and I can still do inline editing if I want.
So what ING needed to support was the sort of theming experience that Nathan Curtis was talking about earlier. So they have a bunch of different brands across the globe, and they wanted to create a singular design system that would support that. And then they wanted to be able to edit no matter what sort of brand was using those components. And they were able to do that using web components and then using a single page application inside of, at the time, Hippo CMS, but now Bloomreach's CMS. And that seems pretty powerful to me. So let's see, what kind of score should we give them? Maybe we'll give AM 3/4 because they only support Angular and React, and so I can't be confident that we can get our web components in, or 100% confident, but I think we'll be able to get them in there. And Bloomreach, I'm going to give them full credit because ING has shown that they can actually make web components work inside of their system. For our final CMS, we're going to look at Storyblock. And Storyblock is a CMS that I was unfamiliar with. It's a headless CMS. It's one that Paul found that had features that allows us to integrate with components. And perhaps most importantly, it isn't enterprise. It is actually pretty inexpensive, which meant that we could sign up for a free trial, or if we needed to sign up for even the premium service, it wouldn't break the bank, unlike some of the enterprise products. So let's take a look at what we found. In order to make Storyblock work, we had to create a server where we would serve up the pages that the CMS was editing. So we built a Express server and a series of web pages that consume the Storyblock headless API. And so you can see an example of this. This is the socks page. And if we look at it inside of the Storyblock CMS, we can see that it's actually editing that same URL, and we can see the same page as here. As we make changes, for example, if we go in and change the number of ratings to 5, and then we save the page, we can see that the components are live. The code that we're using is available to us, and the page itself is getting updated as we make those changes. Unfortunately, it doesn't auto-refresh, which I think is part of what Bloomreach and Adobe Experience Manager are doing with their SPA editing systems. But we can, sort of understand why that's the case. This is a startup, and it's, it's a less expensive product. We can also add blocks to the page. So we could add a container, and inside that container, we're going to add, say, a column. And that column is going to be a half column, and we're going to add a button inside of that column, and we'll have that button say, "Hello World." Now, again, we have to save it before we see that take place, but now we've got a container and we've got a button inside of it. You can see the power here. Even if it is a little clunky and not quite as easy as the other systems promised, it does show us that we can take our web components and bring them into a CMS and have them become the main editing interface for that content management system. And I think that that is a really powerful way of editing content. And with that, we've completed our map. We haven't been able to fill in every spot, but we've done a pretty good job. So we've been looking at all these pieces individually, but I want to bring them all together to look at sort of the wealth that we've been able to create here from that single set of components. So we've got our Stencil components and all of the different features of them, all of the different versions that can be done in terms of building web pages. We've documented them in Storybook so that somebody could then mess with the knobs and see the documentation and see how to use it. We have a very simple version of them available to us in Express using standard vanilla web components. We have Angular application. We've got a React version of the application. We've got a Vue version of the application, an Ember version of it. We now have a web page that's available to us in a CMS so that we can then make those edits inside of Storybook. We have UXPin consuming the components with the little bugs, but really promising, and I think it'll get there. And then in Framer X, we have full designs happening, and we're able to sort of create things using those components. And now that we've got it all distributed, what happens if we need to make a change? What if we actually wanted to change the color of the stars from orange to green? How would that work? Well, we save that change, and the Stencil component automatically updates with the new green. Storybook needs to reload in order to see the new version of it. Express also has to reload. Angular picks it up automatically. React picks it up automatically. Vue picks it up automatically. Ember, for some reason, actually needs to be stopped and restarted, but that's easy enough. And UXPin actually has the same thing, so let's go ahead and do that while we're here. In the meantime, we'll look at some other stuff. Storyblock, if we just reload it, it has green. Same thing in the UI. Oh, UXPin is loading, so I'm going to close that other version. UXPin is loaded, and it also has green stars, and the Ember application now has green stars. And if we move over to the Framer desktop application and we close this document and we reopen it, what we will find is, yes, let's zoom in. We have green stars. So that is a simple example, one CSS change, but you can imagine in a large organization making a simple change to a web component or to a piece of your design system and waiting a long time before it's distributed out to all the teams using their different JavaScript frameworks or their different design tools or whatever CMS they're using. And in this sort of world, we could actually have a bunch of downstream consumers of our design system inheriting whatever changes we make as we make them. And that is really, really powerful. So one final question remains. Is this dream that I described earlier of being able to have components, design components, that then are consumed by different teams using different tools, is it a reality now? Well, it's not fully a reality yet. We've seen a couple places where it breaks down, but it's much further along than it's ever been before. In fact, At Cloud4, we've been so encouraged by the results of this experiment that we've started using this combination of technology, web components, Stencil, Storybook, to create design systems for our clients. In particular for larger clients who have teams who are using different JavaScript frameworks, who want to make sure that they've sort of future-proofed their work for whatever may come down the road. And by designing our components with web standards, we make sure that we can transform them into whatever the most exciting frameworks of the future are. And ideally, we can leverage them in the content management systems and the design tools of the future. So we're much closer to that dream being a reality than we've ever been in the past. Thank you. And thank you to everyone who made this possible. Thank you to the folks at AAA for bringing us all together in the midst of the pandemic. Thank you in particular to Paul, my colleague, who made this experiment possible.